Hello friends, welcome back my YouTube channel. I'm M.Sc. In this video I will discuss the basics of group theory, and this is the part 4. You can watch all my previous videos in the playlist of group theory at M.Sc. YouTube channel. So in this video I will discuss the construction of some important sets and its definition. Okay, we'll discuss what is the Zn, what is Un, what is R of star, what is C star, and what is Zi star, that I will discuss in this particular video. Please be with the video. This is helpful for all these examination: IIT, CUET, NBHM, okay, TIFR, CSIR-NET and GATE. And my name is Manoj Solanki. Let's start the topic and subscribe the channel M.Sc. If you like the video, and please share and subscribe the channel M.Sc. Next, start with the topic. So first of all I will discuss some basic sets. So if we'll start with basic set, then we have so many basic sets. We'll start it from set of natural number. Okay, set of natural number that we are going to define like this n, and after that we have set Zn. Okay, what is this? This will start from 1 up to infinity, and this is the set in which we are taking 0 plus minus 1 plus minus 2 whatever. And then after we are going to define q, that is something p by q, where q does not equals to 0. This is the set, and p and q are relatively prime. Okay, and after that if it is q of c, then we are taking as all irrational number, where like root 2, root 3, pi, whatever the value we are taking inside the irrational number. If I'm going to taking real number, set of real number is nothing but q union q of c, that is the set of real number. And set of complex number is something x plus iota y, where x and y belonging from the real number itself. So these are the basic sets. Now in this video I will discuss the sets other than these set. Okay, I will take help from this, but I will discuss all the other set that will be group in the group theory, and that will have some important properties in the group theory. Let's start the topic. So construction of Zn. What do you mean by Z? And in subscript we have n. Okay, Zn is something like that 0, 1, 2, and it is taking only the positive value. So from here we can say that it is taking positive value. Now which kind of value? Set of all residue, or we can say remainder class of modulo n. So we should have an idea about the modulo n, that I have already discussed in my previous videos. Okay, so basically from here this is 0, and we are taking the residue class, means remainder that we are going to discuss. How can we find the remainder? If we are going to take 0, then it is 0 residue. This is the notation of residue or the remainder. Then we can take 0. Okay, 0 is equals to all x belong from the integer. We'll take all the x belonging from the integers. Okay, then after my n is dividing to x minus of that number, x minus of 0, and how many elements are there, that we will write inside the z of n. Okay, and that is 1 power 1. Then I will take all those n who divides x minus 1, who divides x minus 2, and so on x minus 1. If I will take, it will go up to n minus 1. Okay, if I will write n minus 1, then that is n minus 1 bar. It means n minus 1 bar residue is something x belonging from z, and divides x n minus of 1. Okay, this is the set. Now it means from here, what can I say? That can we construct every time? If I will construct, let's say z of 2, then how can I construct like this? That we will show in the next slide. Okay, what is the cardinality of this set? The cardinality of this set is something z of n. If it is z2, then the cardinality of this set is 2. It means 2 elements are there in the set. If it is z4, it means the cardinality of that set is 4. Now I will take this construction of z4. So how can I construct of Z4? First of all, in Z4, what are the elements? Obviously 0, 1, 2 and 3. So these 4 elements will be there. So we'll check 0, 1, 2, 3. Whose remainder is 0, 1, 2 and 3? So it is very clear. So if I will divide 4, to x minus 0, then it will be 0. Then of course it will be 0 plus minus 4 whose remainder is 0, plus minus 8 plus minus 12 and so on. So if I will divide with these x, then it will be 0, and it is from where? It is from z is equals to integer. These are the integers. Okay, now if I will divide x minus 1 by 4, then the remainder is 1 only. How the remainder is 1, you can say, if it is 1, 1 minus 1 0, 4 divide 0, yes. Then after it is what, x is, if I will take x is equals to 1, then it is okay. X is equals to 2, so 2 minus 1, 4 does not divide 1. Okay, if it is 2 minus 1, that is what, 1, and 4 does not divide 1. If I will take any, like x is equals to 3, that is 3 minus 1 2, 4 does not divides 2. 4 minus 1 I can't take, that is again 0. So if it is 4, x is equals to 5, then it is 4, and 4 divide 1, 4 divide 4, then it can be 5. After that it can be 9. Okay, after that it can be 1 5 9. Because of that, if I will write like this, 9 minus 1, that is 8, and 4 divides 8. Okay, then from here, now it is for only positive. How can I write for negative from here? So if I will write for negative, then that is minus of something like that. It is what, x minus 1. Then can I write minus of 1 here? Minus of 1 minus 1, that is minus of 2. 4 does not divides 2. Minus of 2 minus 1, minus 3. Minus of 3 minus 1, that is minus 1. Then I can write minus of 3 here. Then just take minus 4 minus 1 minus 5, minus 5 minus 1 minus 6, minus 6 minus 1 minus 7, minus 7 minus 1, that is minus 8, and 4 divides minus 8, it means here it is minus of 7. So in this manner we can take these kind of x here. So from here what can I do? I can write like 2. Okay, and then what can I write here? I can just write what, 6 minus 2, that is 4. I can write 6. I can write 10. 10 minus 2, that is 8, and 8 is dividing by this. I can write like 10 here. These are positive quantity. What can be the negative quantity here? If you will write minus 2, that is minus 4, you can write here minus of 2 as negative quantity. After that, if it is minus 3, minus 2, minus 5, minus 4, minus 2, minus 6, minus 5, minus 2, minus 7, minus 6, minus 2, that is minus 8, then I can write minus 6 here. Okay, so this is the negative term which will be in this set. And from here you can write just like 3, and after that x minus of 3, you can just write what, x minus of 3, which will be divided by 4. Then it will be 1 minus 3, it can't. Okay, from 3, next from 3, 3 minus 4 minus 3, x is equals to 4, will not divide. X is equals to 5, which will be 2. 6 minus 3, which will be 3. Okay, 7 minus 3, that will be what, 4. It means that 7 can be here. So next what can be here? So if it is 7, then 8 minus 3, that is 5, 9 minus 3, that is 6, and 10 minus 3, that is 7, 11 minus 3, that is 8. Can write 11 here. These are positive quantity. Now in negative quantity, how can I write like this? Just take from here, that is what, minus 1 minus 3. Minus 1 minus 3, yes, we can write minus 1 here. So next, if it is minus 2 minus 3 minus 5, minus 3 minus 3 minus 6, minus 4 minus 3 minus 7, minus 5 minus 3, yes, we can write minus 5 here. Okay, so these are the negative quantity which will be divided by 3 in x minus of 3. So these are satisfying. So these are the value of Z4, and this is the construction how we can find the Z4. Now what is the value in Z5? That is the 0, 1, 2, 3 and 4. So the cardinality of Z5 is going to be 5. 4 plus 1, that is 5. So this is how you can calculate the construction of these Zn. Now next we have construction of set Un. What is the Un set? First of all, the definition is x belonging from natural number. In that Z, x belonging from integers. Now here x belonging from natural number from 1 to n. We will take all these values from 1 to n whose GCD with n is equals to 1. Okay, just find 15, U15. Okay, U15 means I will take x from where 1 to 15. It means my x will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 up to 15. Okay, now whose GCD with, I will take these x here. Okay, let's say this is my x with 15 is equals to 1. Now I will just write what from here 1 GCD with 15, that is 1, yes. Okay, 2 GCD with, yes. 3, no. 4 GCD with 15, okay. 5 GCD with 15, no. 6, okay. 7, okay. 8, okay. 9 GCD with 15, no. Both are divided by 3. 10 can't be, yeah. 11, yes. This can't be. This 14, yes. This can't be. So means that element in the set are what? So from here U15 is what? 1, 2, 4, 6, okay, 7, 8, 11, 13, 14. So this is the U15. Now how many elements? It means the cardinality you can find phi of n. What is phi of n? Euler phi function. Phi 15 is what? So phi 3 into 5. It is what? Phi 3 into phi 5. It is what? Simple. If you have phi of prime number, then that is p minus of 1. So 3 minus 1, then 5 minus 1. It means 2 into 4. That is 8. Just calculate 4 and 4. These are 8. 1, 2, 3, 4, 5. Wait, I have taken one. Oh, 6 can't be. Sorry, 6 can't be there. 6 can't be there. Yeah, these both are dividing by 3. So this is the U15. Now can you find U25? Easily you can find with 1. Okay, 2, 3, 4, 5 can't be there. 6, 7, 8, 9, 10 can't be there. 11, 12, 13, okay, 14, then 15 can't be there. Okay, 15, 16, yes. 17, 18, 19, 21, 22, 23 and 24. So with whose GCD is 1? Just take phi of 15. Phi of 25 is nothing but phi of 5 power 2, and that is what? 5 p power n. That is p power n minus p power n minus 1. So it means 25 minus 5, that is 20. Just take it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 elements are there. It means this is what? U25. This is how we can construct U or the UN. Now we have some special sets. R star. What is R? R is something real number in which we have Q and rational and irrational number. What do you mean by R star? Whenever you are defining R star, it means X inverse is exist. So for each element, inverse is exist. Okay. For what? 1 inverse with respect to multiplication 1 by 1. 2 inverse with respect to multiplication 1 by 2. What about 0? Can I write 1 by 0? Infinity does not belonging from real number. It means the set in which no infinity is there, that is something R star. Oh, sorry, no infinity, no 0 is there, whose inverse is not exist. So this is what the thing. Next, in C star also, star means that 0 is not there. Q star, no 0 is there. Z star, only those elements whose multiplicative inverse is there. Okay, just take it what? From integer I will take 2. Okay, from integer I will take 2. What is the multiplicative inverse? That is 1 by 2, but this 1 by 2 does not belonging from Z, means it is the not part of Z star. So there are only 2 elements, minus 1 and 1, whose inverse, minus 1 inverse is what? 1 upon minus 1, that is again minus 1, and it is belonging from Z. 1 and its inverse is 1 only, and it is belonging from Z. So these two elements are only in Z star. This is one of the important, you can take it an important note. 1 and minus 1 is known as Z of star. Now if you will take Z iota star, this Z iota means something like this, in which A and B are the integer numbers. Okay, these are the integers number, and if you are taking the star, so these are the value in this 1 minus 1 iota and minus iota, whose inverse will exist. Okay, this is the set, and we have discussed some important set and its construction. So thanks for watching my video. Keep watching MS Maths, and this is all about the topic. Keep supporting, keep subscribing, like the video, share the video, and subscribe the channel. Thank you. Bye bye.